That's what it's mostly used for. If you go back in time, if you go whichever direction you think about, a little bit past these really old things, where you, like, imagine trying to understand what happened here. This stuff has been heated and mushed up and it's a big mess. If you go a little forward in time to now 3.5 billion years, life has been around for 600 or 700 million years by now. And this is the first evidence we can find of really preserved rocks that still show the evidence of life. These things are called stromatolites. Maybe some stromatolites there. I got some. If anybody wants to see these things up close, these rocks are fossils that are probably the oldest fossils that any of you will ever be able to touch. So I would love to share them, so come up and look at them. There are these little layers that you can see in here, They're basically slime mats that formed in water environments. A mat of microbes goes down, water goes away, water comes back, another mat goes down, and they make there's sand in between, and they make these mats. 3.5 billion years old, and if we want to understand the origin of life on Earth, this is the oldest we have, and we're 700 million years too late. There's nothing we can do. We cannot really do a good job of understanding the origin of life on Earth by looking at these places on Earth. So what are we going to do? Well, there's one place we can think about where we can actually see some really old rocks. This is not just the other side of the 10, like it looks like. This is, in fact, the surface of Mars. These are old volcanic rocks on the surface, dunes on the surface. It does kind of look like just across the 210. On the surface of Mars is very different from the surface of Earth for two really good reasons. One, it doesn't rain on Mars. It rains on the Earth. All the sand that you see around here has been washed down from the mountains. It loses its context. We don't know where it came from or how old it is. It comes down. So rain really erodes things away. You can't see them. The other big thing that happens on the Earth that doesn't happen on Mars is plate tectonics. Plate tectonics builds new rock by pulling the ocean basins apart. Rock comes in. We have volcanoes that come in. We have old rock that goes underground. It subducts underneath these things. So we basically recycle the Earth's surface every 500 million years. 500 million years seems like a long time. That is something like a tenth of the age of the Earth. We really don't see much stuff that's older than about a tenth of the age of the Earth. Mars, in contrast, does not have any of those. And so if you look on Mars, all of this brown stuff, this is a map of Mars, I'll show you more in detail, but all this brown stuff is stuff that is older than 3.7 billion years old. 3.7 is kind of that key when life was starting to evolve on Earth, and older than anything we can really see on Earth. All this brown stuff. There's younger stuff. There's stuff that's been covered probably in water. There's middle-aged volcanic stuff, but there's some really old stuff. And if you go look at that really old stuff on Mars, you see something a little weird. That's weird. Okay, craters, fine, that's not weird. But one of the things you see is these things that look very much like river valleys. They look like what we would call dendritic channels. Dendritic channels means, it's the same word that we use for the veins in a leaf. It means, when you see that as a geologist, you think, it means it has rained. It rains here, and there's a little basin here, and the water flows, and gets down into bigger channels, and bigger channels, and bigger channels. 3.8 billion years ago on Mars, it actually did rain. It hasn't rained since then, but it did rain back in that. And this will matter here in a minute. But this really old stuff tells you that there was water on Mars 3.8 billion years ago, and that this surface is still here. This is a 3.8 billion year old surface. So, if you want to understand the origin of life on the Earth, the best place to go look, probably, is Mars. So let's go. So, as Tom talked a little bit about at the beginning, Caltech founded JPL, now manages JPL, works closely with JPL, and JPL, together with people at Caltech, sent you guys, I'm sure many of you were here at this talk in, I don't remember the year now, was it 2015, someone said? 2015. I was only 10. In 2015, you got to talk on the first big Mars rover. The second one has now landed during the pandemic, and it's landed in this amazing spot. Here's the amazing spot it's landed in. This is called Jezero Crater, and here's why it's amazing. First off, It is a crater that itself is something like 3.8, 3.9 billion years old. And you see two things that are key. One is you kind of see this river channel coming in through here like this and breaching the wall. There's a crater wall. You know how craters go, you smack a crater in, it gets walls on the outside. There's high walls all the way through here. It breaches the wall and looks like it flowed into the crater itself. And then there's something, I'll show you this in detail in a minute, there's something that if you're a geologist or someone who likes to stare out the window as you fly across the country, looks like a delta. It looks like a place where water, or sediment and water flows into a big standing lake. Another really key thing is on the other side of the crater. Here's again, crater wall, crater wall, crater wall. Whoa! There's water flowing out the crater wall. This whole thing, 3.7 billion years ago, again, 3.7 billion years ago, where we have almost nothing on the Earth at all. This whole crater was a lake. It was covered in water. We think. So one of the things that you need to know is, one of the things you need to do if you want to try to study these things, understand the origin of life in a place like this, you need to go there and first make sure that you know what you're talking about. Was this really a lake? You know, we see these things, but you know, it's easy to make up stories when you see things. But you fly there and you land there and you can really understand what's going on. Here's an image that's sort of astounding. This is on the way down to land in this crater. And here's this thing that looked like the delta again. And the way a delta works is that the top of this thing would be where the water level was, and this would be where the sediment comes down. But let's see if this is really true. So we land in this crater and start to drive around and look to see what's there. And one of the most, you might not believe it, but this is one of the most astounding pictures from Mars. Okay, it doesn't look that exciting, but check out these flat layers on top, things that come down just like this on a constant slope like this, and a flat layer down here. What is that? That's a picture right on the side of that place that we think might be a delta. Therefore, we think this might be a lake. And it looks like this. Why does it look like this? Well, here's an experiment you can do in the lab for entertainment. This is a layer of water. The water is right here, and there's sand coming down right here. And every once in a while, we throw in a little black sand just to make it, you can see what's going in. So you're going to watch water and sand come down like this, hit the water, hit the layer of water right here, and then build structures in through here. So let's go. Sand is coming in. You see the sand, it hits here, and it goes out, and it goes out, and it goes down like this. See how it goes down like this? As it continues to build, it continues to move out, and it looks just like that. Do you know why it looks like that? Because it's a freaking delta, that's why. There was a lake in this crater on